Okay, problem number 39. We're given a circuit with 4 capacitors. 2 of them are in series with a third system. These 2 are in parallel. So we can sum these up and effectively have 3 capacitors in series. And we're asked to find CEQ, or equivalent capacitance. First thing we want to do is sum these up. So these were in parallel, right? And as before, we take capacitors in parallel. We just add them straight up. So 6 microfarads plus 2 microfarads is equal to 8 microfarads. And then we are going to add these up in series. And in series, capacitance is going to be, we add them as the inverse. It would be, let's just write it like this. 1 over 8 plus 1 over 8 plus 1 over 8. These are all in microfarads. So that means that the equivalent capacitance for the whole series is 8 over 3 microfarads. Okay, next we are asked to find the stored charge on each on each capacitor. It's going to be easier if we define these corners so that we can if we label these corners to define segments along the circuit. So what we're going to do, we'll come down here. See, I've added A, B, C, and D so that we can sort of look at these a little more broken up. Okay, so in series, the charge on this system, in series, the charge is going to be added up, is going to be equivalent, is what I'm trying to say. So what that means is the charge here is going to be the same as the charge here, is going to be the same as the charge here. Right? So we write this out as follows. C equivalence times the change in the potential, right? In electric potential, we're actually told it's a 9-volt battery, so we have 8/3 microfarads, which is what we just found a minute ago, times 9 volts. This is 3. That goes away. That gives us 24 microcoulombs. That's the charge. Excuse me. So now we know that we're going to have 24 microcoulombs along here. We're going to have 24 microcoulombs along here, and we're going to have 24 microcoulombs along here, but we need to break, that's going to be a different scenario. We have to break that up a little differently. So let's just say that QAB, segment AB, is equal to Q segment CD is equal to 24 microcoulombs. Okay, not quite done, but that's this one and this one. And then, but now because 24 microcoulombs goes along this segment, these are not going to be equivalent. These have different capacitances, right? So we need to find out what is the change in the potential for this system here. So we can do that. Let's say delta VBC for that segment on top is going to be equal to QBC over the capacitance of BC. And we know that it's 24 microcoulombs for this segment, right? We've already said that. And we also know that the equivalent capacitance for this segment is 8 microfarads. Right? So that gives us 3 volts. That's the potential difference along this segment. Now we can use that to find, we'll say Q2. So we want the stored charge on the 2 microfarad capacitor times the change in the potential we just found for the segment is going to equal 6 microcoulombs. And then for the 6 microfarad capacitor, we take the potential difference we found for that segment, and we end up with 18 microcoulombs. Okay? So for each capacitor, this is 24 microcoulombs, this is 24 microcoulombs, this is 18 microcoulombs, and that was 6, right? Yeah, 18 and 6 microcoulombs. Next thing we're asked to find is the potential difference on each capacitor. Okay, well, we kind of did this already, but we'll just write it out explicitly here. So we're using this law, this formula, and then so we're going to say on the 2 microfarad capacitor, we have 6 microcoulombs over 2 microfarads, right? That's going to give you 3 volts. On the 6 microfarad capacitor, we have 18 microcoulombs over 6 microfarads. Remember, we just found this, but we can also do it for the other ones too. The reason I'm writing this out is just because I would like to have them all in the same place. So now for the 8 microfarad capacitor, we have 24 microcoulombs over 8 microfarads. That gives us 3 volts. So they're the same. And I believe that's it for that problem.